Hi everyone, here's one more stoichiometry problem, this one with a decomposition reaction. So let's take a look at this. This problem says oxygen is produced in the decomposition of potassium chlorate. Now remember, a decomposition reaction is when you have one compound and it turns into multiple. It breaks down. That's why it's called decomposition. It breaks down into multiple compounds. And a general rule of thumb that you're going to learn today is that anything with the chlorate in it, when it decomposes, breaks down into oxygen gas plus some kind of salt. And that's what's happening in this problem. So we're decomposing potassium chlorate. So potassium chlorate is going to be a reactant. Now remember, potassium is a +1 ion, and chlorate is ClO3 with a -1 charge. So potassium chlorate is simply KClO3. It's going to decompose into oxygen and a salt, and the salt, you may be familiar with salt as being NaCl, sodium chloride, but KCl is also a salt. It's not a salt you'd want to eat, but it is a salt, okay? So potassium chlorate turns into oxygen gas and potassium chloride salt. Now we need to balance this, and we've got the odd-even rule going on here. So let's put a 2 in front of that oxygen. That'll give us 6 oxygens. So we'll put a 3 in front of this oxygen. That'll give us 6. So our oxygens are fine. And since we have 2 potassium chlorates, we're going to need 2 potassium chloride salts. So now we've got our balanced chemical equation. That's step 1. Step 1 in a stoichiometry problem is always write the balanced chemical equation first. Now step number 2 is take what they give you in the problem and convert it into moles. So we have 49.89 grams of potassium chlorate, and we need to turn that into moles. So we're going to put grams of potassium chlorate on the bottom, 1 mole potassium chlorate on the top. So we need to figure out the molar mass of potassium chlorate. So if we look this up in the periodic table, potassium is 39.098, chlorine is 35.45, oxygen is 15.99. Those are off in the periodic table. You have just 1 potassium, 1 chlorine, but you have 3 oxygens. So that's 39.098 coming from the potassium, 35.45 coming from the chlorine, and 47.97 coming from the oxygen. And if you add that all up, it works out to be 122.518 grams per mole. So we're going to move that here, 122.518. Hope you guys can read that. 518. Okay. Let me fix that a bit. 122.518 grams. There you go. That's better. All right. So we're taking our given and turning it into moles. That's step 2. Step number 3 is to use the mole ratio from the balanced chemical equation. So we want to get rid of moles of potassium chlorate. And the problem is asking us how much oxygen is produced. So that means we need to have moles of oxygen on the top of our mole ratio. And remember, one of the reasons the balanced chemical equation is so important is that the numbers you put in your mole ratio come from the coefficients in the balanced chemical equation. The coefficient in front of oxygen is 3. The coefficient in front of potassium chlorate is 2. So that's step number 3. Step 1, balanced chemical equation. Step 2, convert what they gave you into moles. Step 3, use your mole ratio. And step 4, convert your answer into the desired units. And they're asking you how much oxygen in grams is produced, which means we're going to need grams of O2 on top, moles of O2 on the bottom. And we already know that oxygen is 15.99, so O2 is just going to be double that, which is going to be 31.98 grams. So there's 31.98 grams of oxygen per mole of oxygen. All right. Now, before we put this in our calculator, let's check our setup and see if our units cancel out properly. Grams of potassium chlorate cancel, moles of potassium chlorate cancel, and moles of oxygen cancel. The only unit we're left with is grams of oxygen, and they wanted our answer and how much oxygen is grams, so we probably set this up right. Now let's bust out our calculators. 49.89 times 3 times 31.98 divided by 122.518 divided by 2. And when I crank that out, what did I get on this one? Oh, I've got it right up here. I get 19.54 grams of oxygen. All right? So just to review, 4 steps are write the balanced chemical equation. Second step, convert what they gave you in the problem into moles. Third step, use your mole ratio from the balanced chemical equation. Remember, what you want to get rid of goes on the bottom of the mole ratio. What you want to end up with goes on the top. And the fourth and final step is to convert those moles into whatever unit the question is requesting. Alrighty? Okay, have a great day. Next week, we're going to start working on multi-step combustion problems. Have a great day, you guys. Bye.